Assalamualaikum and hello to everyone, especially to Dr. Salama, our esteemed algorithm and complexity lecturer for the course BIE20203. So my name is Arif and I'm here to representing our group, which is group 2. So we are excited to discuss our project on efficient road planning, a case study of shortest path algorithm in urban traffic. So for this project, we have utilized PHP, a prominent backend programming language, along with the HTML for the structure, CSS for the styling, and JavaScript for the interactivity, as we aim to imitate the Grab application. So we have implemented 3 algorithms, which are the Dijkstra, Bellman-Ford, and Floyd-Warshall Algorithm to determine the shortest path in urban traffic. So this algorithm were crucial in optimizing road planning and ensuring efficient navigation. So we have implement Visual Studio Code as our IDE and XAMPP for local hosting, which facilitate efficient coding and debugging. So this tool provides us with a conducive environment for developing a robust and functional road planning system. So without further delay, let's dive into the key point we have prepared for this presentation.
Okay, let's jump to the key people first. So actually this group consists of 4 members. So for the first, we have Nurin Rusdina. Next, we have Siti Anur Bashira. And the next, we have Pruti Khairin Jasmine. And the last one, we have Arif Azinuddin, which is me. So without further delay, we go to the content outline. So this presentation consists of 5 contents. So for the first, we have introduction. Next, we have algorithm chosen, why, demonstration, algorithm comparison, and the conclusion. So we jump to the introduction. So the shortest path problem involved in determining the most efficient road from the starting point to a destination. So we have applied to Kuala Lumpur International Airport, which is KLIA, and its various destinations. Demonstrate using the Grab ride-hailing service for the practical implementation. And Grab utilized the shortest path algorithm for the customer convenience to get their destination. So as you can see, there is the network graph of road. So inside these figures, it have 10 nodes or 10 vertices. And we start from the KLIA. After that, we go to the Putrajaya, and after that, from Putrajaya, we have 3 nodes connected with the Putrajaya, which is Petronas Twin Towers, Berjaya Times Square, and Merdeka 118. And after that, it connected with the next nodes or vertices, and every edges have their own different distance. So there is 3 nodes after that, which is Merdeka Square, Bukit Bintang, Exchange 106, Alias TRX. And after that, we have 2 nodes for the last, which is KL Tower and Tabung Haji Tower. So next, let's go to the algorithm chosen. Why? So actually, we have chosen 3 algorithms for determining the road planning. So for the first, we have choose the Dijkstra algorithm. Why we choose that? Because of the optimal and efficient for the single source node. Okay, next for the Bellman-Ford algorithm, we have choose this algorithm due to it provide a simpler implementation for the educational and comparative purpose. Graph with a potential negative weight, but it can handle non-negative weight as well. And the last, we have choose the algorithm Floyd-Warshall due to it compute the shortest path between all pair of vertices simultaneously, and it's suitable when complete path information is needed. So next, we go to the demo session. So we need to activate the Apache first, since it utilizes the PHP for the backend programming language for the backend purpose. So let's go to the home page here. So this one is our interface for the Grab. So we have imitated the Grab application to execute this project. So we have utilized grab logo here, and this one is the home page. So there is the logo here, the menu here for the features and feedback, and there is a button to book now. So it will direct to the book page. So to the booking page. So as you can see, wanna go somewhere, book now. So when I click here, it also will redirect to booking page. So you can see the welcome to the Grab. After that, it have the features for the ride. We can hover on it, and there is more features here for the food, the express, and the hotel. This one is for the immediate purpose. So after that, we have the feedback here. So there is 2 feedback that they leave with 5-star rating. So wanna join us? Carry with Grab. It just like an advertisement to imitate the real application of Grab. So next, when we click join us, it will say thank you for joining us. It just use the JavaScript for interactivity. So there's a features here, and we can click the feedback menu here, and we redirect, and it use the smooth behavior for the CSS styling here. So let's go to the main focus here, which is a booking page. So where you wanna go, choose destination. So kindly select your destination to proceed with your Grab ride booking. So this is a destination, and you are here. So as you can see, it's same as the case study. We start from the KLIA here, and after that we need to choose our destination. The starting point is KLIA here, and we need to go to destination here. So we need to choose from, so I would like to choose Putrajaya, and there is a button for the routing here. So we can click, and we redirect to calculate the distance and all of the components related to algorithm and complexity subject here. So I click here, and we redirect to routing section. It provides efficient routing to ensure you reach your destination smoothly. So it will show these 3 algorithm, the comparison of these 3 algorithm. So it will show the path here in the graphical ways, and it provide the distance, path, time execution, time complexity, usage step count, order of magnitude, or we call it as big O notation, the best case, average case, and the worst case. So when we start from the KLA and we choose the destination to Putrajaya, it show all of these same distance 30 km, and the path we start with the KLA and next Putrajaya. Okay, so for this one, actually we can see the efficient of the Dijkstra, Bellman-Ford, and Floyd-Warshall. The time execution, obviously the Dijkstra is the best because it have the lowest or the least time execution compared to Bellman-Ford, because Dijkstra is 0.09 milliseconds, Bellman-Ford is time execution 0.4 millisecond, and Floyd-Warshall is 0.58 milliseconds. So for the time complexity and big O notation, it actually seems for all these algorithms. For the Dijkstra, the time complexity is O in the bracket E plus V log V. For the Bellman-Ford, the time complexity is O in the bracket VE, and for the Floyd-Warshall, the time complexity is O in the bracket V the power of 3. So for the base case, average case, and the worst case of the Dijkstra, it have the same number here, which is O in the bracket E plus V log V. And next, for the Bellman-Ford, also have the same for the base case, average case, and the worst case, which is O in the bracket VE. And also the last one for the Floyd-Warshall, it have the same base case, average case, and the worst case, which is O in the bracket V power of the 3. So next we can click other destination here. So I think I will go to the situation is you just arrive on KLIA and you need to search for the ride, or we can use the Grab service. And when we search this destination, it will show the routing planning and the best algorithm we have used to have the least time to execute this road planning. So next, I think I will go to the KL tower. So choose KL tower and click routing button here. So we show the kilometer same distance 30 kilometer, and the path also seems. I think because of the distance, it determined by the distance, because there is not so much nodes or vertices that we have provide for this network graph. So I think when we have the more nodes or vertices, it will show the other ways to go, or the other path to go on the selected destination. So as you can see, it's so same the result. The Dijkstra is the most efficient. It shows the time execution 0.04. Meanwhile, for the Bellman-Ford and Floyd-Warshall, it shows there is a much number here. For the Bellman-Ford, we have 0.59 millisecond, and for the Floyd-Warshall, we have 0.41 millisecond. So the ranking is Dijkstra first, and the next we have the Floyd-Warshall, and the last one we have the Bellman-Ford. So I think for the Floyd-Warshall and Bellman-Ford, it have different result for different destination. So I think if you interest to book this Grab, you can click here, click book, and it will say you have booked this ride. Thank you for using this service or our service. So we show the interactivity by using alert JavaScript. So I think that's all for the demo session here. So next we go to the algorithm comparison here. So there is 3 algorithm here we need to compare, since we have choose Dijkstra, Bellman-Ford, and Floyd-Warshall algorithm. So in terms of type of shortest path, for the Dijkstra, the single source find the shortest path from the starting point to all other destination. Next, for the Bellman-Ford, it single source shortest path modified for waypoint. And for Floyd-Warshall, all pair pre-computed shortest path between all cities pair. For the big O, in terms of big O notation, for the Dijkstra, O in the bracket E plus V log V. For the Bellman-Ford is O in the bracket VE, and for the Floyd-Warshall is O in the bracket V the power of 3. Okay, next, for the efficiency, the Dijkstra, the most efficient for dense graph, many edges. Okay, next, for the Bellman-Ford, less efficient than Dijkstra, and Floyd-Warshall algorithm, the least efficient, computationally expensive. Next, for the data suitability, for Dijkstra, the best for standard road network. Bellman-Ford, it suitable for the complex network, and for the Floyd-Warshall, it beneficial for comprehensive road planning with the frequent calculation. Okay, next, for the strength, for Dijkstra, this is the efficient for standard road network, guarantee shortest path. For the Bellman-Ford, can handle negative edge weights, and for the Floyd-Warshall, it's pre-compute all shortest path for fast retrieval. For the weakness, in terms of the weakness of this algorithm, Dijkstra algorithm limited to non-negative edges weight. For the Bellman-Ford, may be slow than Dijkstra for positive edges weight. And Floyd-Warshall, it's not directly applicable for dynamic waypoint, high computation cost. For the implementation consideration, it require for the Dijkstra, it require priority queue data structure for efficiency. For the Bellman-Ford, is straightforward implementation but may require handling negative weight. And for the Floyd-Warshall, it's more complex implementation compared to others. So this one is the conclusion we have arrived in the conclusion section. So the best performance we have choose is the Dijkstra algorithm has the best performance in terms of order of magnitude for the specific case of non-negative weight and dense graph due to its attribute, which is a practical and large scale application like urban road optimization. So it have the efficient node selection process by minimize the number of operations compared to the exhaustive edge realization of Bellman-Ford and all-pace comparison of Floyd-Warshall. So this one is the Q&A session. Since this video is recorded, so we don't need to proceed with this. We can only skip this part. So I think that's all from us. Thank you for lending your ears and attention for watching this video. I hope this video can help you to execute this project. So I have attached this repository on the video description. So if you want to figure out this code or this repository, you can click and the link and it will redirect to my GitHub repository, and you all can download and use for your own purpose. So I think that's all from me. Thank you once again.